Hello everyone. Welcome to FBA First Break AI. Today we are looking at lesson 1B where we will run Qwen3 locally using PureC. Let's look at the lesson page. On the lesson page, we have a hero card which mentions the link to the GitHub repository. Using this repo, you will be able to run Qwen3 locally. Let's look at some salient features of this repo. This repo allows you to run Qwen3 locally on Mac, Windows, or Linux in 3 easy steps. These are the steps that you need to follow to run Qwen3 on your laptop or desktop. The first step is simply to download Qwen3 model, a GGUF file, and place it inside the folder. Second step is to use make command to create a binary executable file. And the third step is to just use this file along with the model file or the GGUF file that you have used and basically run the Qwen3 model locally. So there are a few salient features of this repo. The first is that you can run Qwen3 on Mac or Windows or Linux. The second part is that you can visualize the output of the model and understand decoding using special visualization features. And this visualization feature also works in replay mode, which means that you need not run the file locally. You can even use your previous runs to visualize what was going on inside the model. And you can also learn by changing various knobs like temperature, thinking flags, and much more. So it's a very useful repo. Before we start about this repo, I want to talk about GitHub submodules. This repo basically contains 2 other GitHub repos, and this is via GitHub submodules. So you don't have to pull all 3 repos separately. A single command works really well, and which is called git submodule command. So if you go to the GitHub repo and you go to the quick start section, it's going to mention that you can use this git clone command. So git clone with arguments recursive submodule, and this will not only pull or clone this main repo, but it will clone both the submodules or subrepos along with it. So one command helps you manage the entire submodule. So submodule is very useful when you want to club multiple repos together for your course or for any other reason. This is a learning course, so it's easier to maintain a single repo rather than 3. So the first step is going to be to run or to do a git clone, as I mentioned, but the git clone should not be done in a normal manner. It should be done with a argument of recursive submodule, and then you can cd into the actual repository and then move forward with it, right? So the first step is going to be you will have to cd into the repo, which is qwen3.c. So if you go to the repo itself, you can see there are going to be multiple files. And in this repo, you will have qwen3.c and qwen3.cu. Today we are working on PureC. So you move into this folder. So if you can do ls cd repos, right? Again, if you do ls, you'll list both the repos. Right. So now we are inside our main repo. And as I said, we can work in 3 easy. We can run this repo in 3 easy steps. Those 3 steps being: number 1, download a Qwen3 model file. So to do that, you need to just run this command, which is going to pull a Qwen3.6b FP32 model, and it's going to pull the model Once the model is pulled, you need to move it inside our current file. So you need to move it inside Qwen3.c. So you will, once you have done both the steps, basically pull the model uh, into this particular folder, and then from this folder you're going to move it to our Qwen3.c, which is our core folder. You will see a model file like this called Qwen3 hyphen 0.6b hyphen fp32 point dot gguf, right? So this particular file is very important. This is our main file which we are going to run, right? So if you basically just want to run this file, you will have to go to the terminal. Let's see if this file is here. Yeah, you can see the file. So our main file is run underscore viz.c. This is the file with the entire code. Now comes step 2. You will have to create a binary. This is a binary, right? To create this binary, you have to run the make command. So what you have to do is you have to do make run and give the make run.viz. So we have two binaries here. You can use either run or run underscore viz. So your command is going to be make run underscore viz. Instead of this, we are going to just use make run underscore viz. And once that is done, then we can, once that is done, we can run this executable very easily using this command. So let me expand this box a bit. Here we go. The second command is, so yeah, this is the updated command. Right. So using these two commands, so step 2 is make run underscore viz. Step 3 is dot, which basically tells the system that you have to run this file, and we are going to use this. This is the argument of the file. It requires this argument minimum. There are other arguments as well, but minimum it requires the name of the model file. Right. So using these three, we'll be able to run. So if I am already here, right, and I have completed the make command, we are on step 3. So this should work. So you can see the model is loaded. It is printing what are our flags. Multi-turn is on, thinking is on, other flags are there, temperature, top P, and visualization is off by default, right? So now I can give my system prompt. This is very similar to going to chat GPT and, like typing something like tell me about, and I can basically give my, yeah. So I'm just typing a normal command, right? And let's do instant, let's set website. So, so there isn't, instead let's use something. Tell me about the king in Jungle Book. Just this much, right? And we disable web search. Web search is disabled, and this is our prompt. So yeah, whatever it is the output, right? Now let's see what happens in our local. So first there is a system prompt. We can either skip this or type something like you are an expert writer. And let's give the same prompt. So tell me about the king of the jungle, right? So this is going to run this particular model locally, similar to how whatever model is being run right now, it's 5.5. So GPT 5.5 on Chat GPT, this is your local version of that model, and we will learn how this model works, what is decoding, what are these special tokens, what is a chat template, all these things we'll be able to learn. So basically it's printing things. We stop that, right? So this is how you can run this particular file locally, pretty easy in 3 simple steps. As we mentioned, the 3 steps are, Excalibur is here, yeah. Download the Qwen3 model file and place it inside Qwen3.c. Right? That's our main repo or the main folder in which we are going to work. The second one is go inside this repo and create an executable file. And third is, once this executable file is created, you will be you can start this model, right? So this is how you basically create how do you run this particular file locally. And in the next part, we will look at visualization. Not let's take visualization also in this part, right? So this is about how to run this file, the bare minimum easy way to run this file. As I said, there's a visualization feature as well, right? So for that, what we'll do is we'll open another terminal. So we need 2 terminals for this, right? Where are we? Okay, this is good. So for that, we need to, so there is another repo called, another folder called apps. And this is a basic React Next.js kind of a repo, which allows you to visualize how the model works, right? So when this model was spitting these or giving this output, what we do is we capture everything about the output and put it in a file. So if you go to public, where is public? Post, maybe in assets. Yeah, it's right here, right? There'll be a file called sampling session JSON. So this is going to capture everything as the model thinks, thinking token. All the raw logic data is going to be captured. All the raw data is going to be captured so that we can understand what is going on, so that we also understand what is sampling. Right? So before we do that, we are going to understand why do we need this visualization, right? Why do we need this visualization? For this, we'll have to go to lesson 1. So we'll go to our lessons. Yes, this is lessons. And we'll go to our first lesson, right? Hugging Face and Beyond, where we spoke about 3 intuitions that hold this cohort together, right? The first intuition was that the model is just a stack of repeatable blocks, which we will see practically when we open this particular file. This intuition is actually easy to understand. All you have to do is go to your main repo, or you go to your run or run-this.c file, and this is your code to run that GGUF file. So this is a stack of repeatable blocks. It has an architecture, but basically it's just a stack, right? The second visualization is that at any point, the model is going to give you an output, but it's going to be a single token, a single word, right? So, which we saw that when this particular model was loaded, it didn't give you the entire output in one go. You can see that I have stopped the output. So it started with think, then okay, then comma, then space, then the. Right? It's giving you one token at a time. That's the second intuition. The third one is, which is why we need this visualization, which is very, very difficult to understand, right? Is that when the model was, say, outputting okay, one token, right? It wasn't just outputting okay. It basically gave you an output which was the entire vocabulary. The vocabulary size of this is more than 150K, 150,000. It gave you probability or logics for the entire 150K, right? And we'll see that using our visualization tool. So we are visualizing to understand intuition number 3, which is the most important, is that when the model produces the next token, it does not pick a single one. It produces a probability, a single floating point number for every one of its vocabulary tokens, right? So there are 151936 vocabulary tokens. It's going to give you a number for each of them. You will have to choose, or we'll have to choose which is the best one for us, right? Through a strategy. So we'll see that. Now, as I mentioned, to do this, we need to open another terminal. In the first one, in the main terminal, we are just going to it's just going to basically do the same thing that we did earlier, run the model locally with a command similar to this, right? There'll just be an addition to this command. And in this one, we are going to, in the second terminal, we are going to run another. So we have app number 1, which is a visualization app. We have app number 2 on command line, which is a regular app which runs Qwen3. And we have basically it's app number 1 is going to be a bridge. It's going to use this file to display data to you in a very nice manner. So for all we have to do is if you are running this for the first time, you have to install, you have to do npm install. So you have to just go to cd to tools and do an npm install for the first time. Just one time requirement, right? Similarly, go to cd apps and do an npm install. This is just going to install the required libraries. So this command has to be run for the first time. Once this is done, things are very easy. We have to go to so we cd into this folder for our app number 1. We are into the folder and you do npm install and then you do npm run dev. I've already done npm install, but I'll just do npm run dev. So our first app is live, which is our visualization, which is our visualization part, right? So this opens on localhost 3000. All you have to do is go to your browser and just put this out, right? So this is our visualization app. Right? You'll be able to see something like this, or you'll be able to see on start loading the file. Some homepage will be visible to you. Right. So this is done. Now we'll do our main part, which is running the Qwen3 model, right? So for this, cd into this, then do npm install, which is done. And then all you have to do is run this command. Right? So earlier we basically we just ran this command, right? Run visual. This is a compound command which is running another bridge. So just copy paste this and this. The same prompt is there for you. Again, we'll say you are an expert writer, correct? And now comes our main command. Who was the king in Jungle Book, right? That's it. I have not pressed enter. I'll move my focus to this, right? So let's get ready to hit and see what happens, right? The moment before I do that, before we go live with this, let's see what this is trying to show. So when I click on author, this is okay. Information is okay. Thing jungle, yeah. Let's look at jungle, right? So when the model has already given you the output from all the way from think, okay, the user is asking who is right. The model has reached this point and we are thinking of the next token jungle. We want to understand why did the model at this point output jungle. You can see that these are the top 20 tokens. So we have jungle, but we have star, we have book. We have got story, novel, king, original, Indian, author, children, king, books. There were these tokens, right? Why did this particular model choose jungle and not book and not story or novel or king, right? That's the question. So we are at this point, we are at jungle, right? So the output could have been the jungle book is a book part is not yet done. We are just at this point. Model has, you can ignore the text beyond jungle, right? The jungle, it could have been the movie, it could have been the story, it could have been the king. So if the model would have chosen king, it would have gone into a different direction. Right now it's trying to talk about that the jungle book is a children's fantasy novel, right? So if we hold ourselves at this point and we look at the token, so token is jungle, right? And where is it going after this? Like, what is it talking about? Sorry. After this here is a sampling, right? Basically, this book is a children's story, something like that. So, okay. Yeah. Basically, the jungle is a children's story, right? Something of this kind. It is trying to explain the Jungle Book concept, but let's imagine, let's force the model to pick something else, right? In fact, we can make this enhancement, right? Uh, we can stop the model and we can force it to choose one versus the other. That'll be cool. So let's think of that as a new project. For now, let's just do one thing. Think about, instead of jungle, we would have maybe thinking about, there was a movie, right? The movie or the book. Let's say the movie. Yep. So not here. To Excalibur. This is our current thing. This is our current version. We will copy this here and our path number 2. So these are 2 paths, right? I will on this side is path 1, and we can say part 2 on this side, right? Left side, path 1, part 2. And this is the current one, obviously. This is the current path. Let's highlight that as well. Current path or direction model took. Right? What if the model took a different direction? What are we thinking? What if the model thought or chose something else? Right? So we are thinking that sense, right? Thought experiment. So right now our main focus is with this. So the path is also in terms of jungle. Right. So this is the path, jungle. And what is the other option? Is book, but we can also think of king, or there was movie which is very low. But let's look at movie. In this case, we are thinking of movie. So this is pretty easy to understand, right? Right now, the focus has come to book. But if it was the movie, then it would speak about the movie, right? It would like form the text about the movie. It won't focus on uh, the book. So you would get a very different output if you had stopped at jungle, right? And you would get a very different output if you had stopped at jungle. That's for sure. Correct. So what is this particular visualization telling you? First is that you are creating like a selection criteria, cutoff. Your cutoff is called as top P. What you are saying is that whatever you select, the cumulative has to be greater than 95%. And you are going to discard the rest. So first comes temperature. Temperature allows you to think creatively or not creatively. 0 means you are basically not thinking creatively. You just want the top probability, which is jungle all the time. But there's another one where you basically don't want to do this. You want to sometimes choose a random path, right? So first comes temperature. We are saying we have a temperature of 0.6. We want some variation or change in the thinking, some creativity, right? After temperature scaling is done, you decide the top P and you come up, so you get raw logits and you convert it into probability. You can see that once you do that, certain tokens get very high probability. Like the reason this particular model has chosen jungle is because after we did temperature scaling and we are selecting where we calculated a probability, at this point, jungle has a very high probability. Even though you can see that the logic scores weren't far away, the probability scores are wildly different, right? I mean, star and book are not close enough to jungle. So this is because of this particular flag or knob that we have chosen, right? So this is how this works. Now, there was a unique example in the lesson. A huge lesson, almost requires you to spend more than 2 hours. I think this is the first lesson, the second one. Let's go to a second lesson. So this particular lesson, Qwen3 fundamentals, is like 120 minutes, but probably needs more effort and time, right? So we go to the section at the bottom where we see this creative part, temperature part in action. So a lot of technical things about GGUF model and why it works. So this is the section which talks about the visualization, how nucleus sampling works, top P works, what is temperature, right? So there was let's try and zoom. So similar to the visualization we saw, in this case, our top P cutoff is 95%, which is correct, but our nucleus size is longer because of the probability distribution. You can see there are a lot of answers which are very similar. The model is thinks that all of these tokens have a right to appear, to be chosen, right? So you can see the logit is 18.2 for book, it is 18.2 for story, it is 18.2 for jungle, it is 18.2, but the model has chosen original here. So you can see here it is original. I should clarify that the original book, the original, right? It could have said I should clarify that the original. I should clarify that the story. That could have been the path. I should clarify that the book, but it went for original. Original isn't even the highest logit, or the highest probability. This is your randomness at play. Because our temperature is 0.6, there will be random times where your model will pick uh, not the top probability, but something different. So you can see that this pushes the model into creative zone. It basically pushes the model into, but this is purely at the end, right? So when we think about the model as a stack, the first intuition that we have, the model as a stack. Let me check the recording is going fine. The model as a stack. At that point, basically, we are trying to come. The model is trying to understand your context and trying to give you an answer, right? It's going through those stacks, going through those layers one by one. That is fine. But all of this sampling that you're doing is not actually part of the model thinking. The change is actually post the model has done, because the model is already given you logit scores. There's nothing that you can change. But if you change this particular token, if you decide to choose one token rather than the other, the next one will get impacted. And so the model thinking will change, right? So this is like a weighted lottery where something which had very small chance of winning has won because of a temperature flag, right? Not always picking the top token. Not always picking the top token, but yeah, not always picking the top token, not being greedy. So, but being a bit creative. That's the idea here, right? So the relevant code is here, and float r into probability. CDF is 0, int is 0. I is less than last index. Okay, this is the loop. CDF was set to 0, and we are pulling the probability index dot probability. Okay. And if r is less than the CDF count at this point, we're going to return the index itself. The coin is a uniform random. Okay, the coin is a random number. If it lands in 1.4% slice belonging to original, token run the same prompt. Likely big story. Okay, so if it lands, so this is a sampling. I'm just trying to figure out the exact sampling code and what was the logic behind it. And we can even change this to another code. Probably that should be part of our assignment. If it, who has chosen this 1.4% slice? So let's go to our visualization file and see. Here's the 1.4 is basically he's calculating the probability from not from here, but basically it's just the 1.4 is this probability. Okay, so looking at this again. So the random number is fine. Maybe we can enhance our sampling visualization with this number as well, like what was shown. Right. So a lot of changes can be done here, right? Now let's try and run this in practice. And there are two like changes that we have thought of. Let me like push this to Discord. First break AI. And step 2. Okay, so like thoughts. Thoughts are thoughts. One has thoughts to the first one. Okay, what if halt and choose the model, the token? I can't pull the state behind, right? I can actually pull the token, halt and choose the token. So in Viz, token in Viz. I'm basically trying to say halt and choose the token in Viz and see how model changes path. So when you're thinking of only in sampling. And we can also see the output of whatever was that code. It's called sample from the truncated list, which so it looked at cumulative probability. It took the probability index. Truncate the list where cumulative probability exceeds top. This is fine. Where the cumulative probability exceeds top. So we'll look at this and maybe some changes here. Different quotes. Yeah, these are just thoughts, right? We'll just park this for now and let's see this in action. So once you are at your point and you have started app number 1, app number 2 with our command, right? Let's hit this and you will see this in action. So go here. We'll wait for the first token to come. The time taken for the first token is called TTFT, time to first token. Another very critical criteria of inferencing is TTFT, time to first token. A lot of factors determine TTFT. And we speak of that as well. So our model has started. So you can see we are live, and as the model spits, figure out who the king. So you can click back to live. The character is a young boy named M. Mufasa. So that's how it's splitting the token. But wait, the story is it. So you can see the live score, and you can actually go to any point or any token. Yeah. I had just had to reload. That's it. So this is how it works. So this is how we can run this particular model in Windows, Linux, or on Mac, right? I'm running it on Mac. If you are running it on Windows, just one thing, you should use WSL. It's the easiest. You make sure that WSL is installed. And once WSL is installed, you need to, so I'm using Bash here. Best is to start your terminal, then just do WSL install, right? Once WSL install is done, you can move ahead with your rest of the code. So yeah, for Windows, highly recommend that you use WSL. Correct. We look at faster inferencing, other aspects as well. So this will continue. So this is our first part where we actually see how to run this repo on your local, and basically use this to understand visualization. We have run this particular repo in two ways. One is that we are running it, uh, just running the model, but with visualization, we need to open up another terminal and run the first app, which is visualization app. And once that is up and running, we then run our Qwen3.c repo as well. So this is how you run both these apps together. And we looked at sampling a bit. We looked at other aspects a bit, right? Hope it's easy for you to understand and execute this. So then in the next part, we will look at other aspects of this particular model. We look at the code. We understand other things in this lesson. So see you in the next part.